Class example 1.7.1, evaluate each power. So if we have any base raised to the power of a negative exponent, whatever that negative exponent happens to be, it could be rational, it could be a whole number, it could be anything it likes, it does not change the base. The base stays the same. It simply changes its location. So no negative sign anymore. And what that negative sign simply does is it changes the location of whether the base to the exponent, so a to the power of n, is on a numerator or a denominator. So if I had 1 over a to the power of negative n, it simply says the negative index here, the negative exponent here, is indicating that I am going to swap from numerator to denominator, and that is it. Notice everything else stays the same. The a does not become negative, okay? The negative itself goes away as soon as you change it from top to bottom. That is literally all it does. We could say this is over 1. So if I have 7 to the power of negative 2, I can rewrite that as 1 over 7 to the power of positive 2. Do not change the 7 to a negative, nothing along those lines. And in this particular case here, I have 1 over 7 squared, and 1 over 7 squared is 49. So 7 to the power of negative 2 equals 1 over 49. 1 over 4 to the power of negative 2. The negative sign simply indicates that we change its location from the bottom, this time to the top. So I get 4 to the power of positive 2, because the second I swap it, that means that I'm applying the negative sign. And from here, I know anything over 1 is itself, and 4 squared happens to equal to 16. So 1 over 4 to the power of negative 2 equals 16. Negative 6 over 5, all raised to the power of negative 3. There's a few things that we can do here. We can apply the negative first, or we can apply the 3 first. I say let's apply the negative first. When we apply the negative, it changes nothing. It changes nothing at all. Everything else will be exactly the same. It'll change into a positive 3 because we're applying it. And whatever is on the bottom changes locations to the top, and whatever is on the top changes locations to the bottom. So negative 6 over 5 to the power of negative 3 becomes 5 over negative 6 to the power of positive 3. And now we can go back to our Math 9 rules and say that that's going to be 5 to the power of 3 as well as negative 6 to the power of 3. 5 cubed is 125, and 6 cubed is 216, but don't forget that's a negative 6 multiplied by a negative 6 multiplied by another negative 6. 2 of my negatives cancels out, but my third does not, so that would be negative 216 on the denominator. So negative 6 over 5 to the power of negative 3 becomes 125 divided by negative 216.